All right, this is Coach Williams, and we are doing the the mid-chapter test for Chapter 5. We are going to go over the problems that we went over for our homework check, and we've added a couple of problems here just so that we can get a little extra practice on that. The first part's pretty easy. We're going to determine whether the ordered pair is a solution to the system of linear equations. And I might mention, too, some of you guys may have a little different title here. Yours may still say homework check. But as long as you have 3 problems here at the top, then you've got the right paper, and 2 graph examples here, then you've got the right paper. We did make some modifications before we revised this video. So anyway, we are going to go over this. The test is going to be 12/12 Monday. Obviously, for those in Algebra 1 in 2016 right now. And you can use a standard note card for a cheat sheet. You can put whatever you want to on that standard size note card, front and back, and you can use that for a cheat sheet on the test that will be on Monday. And we will have this video posted for you guys so that you can use Google Classroom, YouTube to do some more reviewing over the weekend. All right, so let's get started here. All we have to do is plug in the x and the y's to find out if these equations are true when we plug these values in. And if it does make both equations true, this is an all or nothing. If both equations are true with this coordinate or this ordered pair, then we know it's a solution to the system of linear equations, and that's what we're dealing with in Chapter 5, is linear equation systems. Okay, so here we go. Let's plug in a 3 and a 4 for y, 3 for x, 4 for y. It's supposed to equal 7, and it does. We know that 3 plus 4 is 7, and so we know that checks out. Let's plug in a 3 for x here and a 4 for y here, and this is supposed to equal -5. Well, 3 minus 2 times 4 is 8. Supposed to equal -5, and that is a -5. So that one also checks out. This is going to be a yes. This is the solution. This ordered pair is the solution to this system of linear equations. On the second example here, 1b, we plug in for y. This is a little different order. So we're plugging in 2 for y. We're going to take -5 minus 3. Well, that's the same thing as +5, and we know that +5 minus 3 does equal 2, so that first equation checks out. The bottom equation, again, 2 is y. 3 times -5 plus 10. This is going to be a -15 when we multiply 3 times -5 plus the 10. It's supposed to equal -2. Let's see if it does. This is going to be a -5, and -5 is not -2. So this is going to be a big fat no. And that's all we're really supposed to be doing here. We're supposed to say yes or no, depending on whether they make both equations true or any of them not. And again, it's an all or none. So we'll plug in here a 3 for x and a 2 for y and see if it's going to equal 9 when we multiply these terms here. And I'm going to do this in 2 separate spots here. I'm going to do the first equation over here. So we have 7 times 3 minus 6 times 2 is supposed to equal 9. This will be 21. This will be 12. And 21 minus 12 is 9. So this one checks out. The second equation is going to be 5 times 3, 2 times 2, sorry about that, equals 19. Well, 5 times 3 is 15. 2 times 2 is 4, and that's supposed to equal 19. And 15 plus 4 is 19, so that one checks out. So this is going to be a yes. So we have yes, no, yes for the first 3 examples. Those are pretty simple. You're just plugging the values in to see if they're going to work or not. You need to use that as you move along because you can check your own answers by plugging the values in. So if we'll plug the values in, after we think we found a solution, then we'll always be able to tell if it is or is not. Here we're going to use the graph to help us solve linear equations and check our solution. If you'll notice these lines, they come together and it's hard to tell where they are. You can kind of use the grid lines, though, to help you find the location. In this case here, it looks like it's here. We're going to make that assumption, and then we're going to check it. And this point is at 2 in the x direction. Okay, so coming from the origin in the x direction, positive 2. And then we go down, or in the negative direction for y, negative 4. All right, so we believe that the solution is going to be 2, negative 4. Let's check it. Well, if we plug into the first equation, 5 times 2 plus 2 times a negative 4 is supposed to equal 2. Well, 5 times 2 is 10. 2 times a negative 4 is a negative 8. And 10 minus 8 is 2, and 2 equals 2, so that part checks out. The next equation is 3 times 2 plus a negative 4 is going to equal 2, or is supposed to. 3 times 2 is 6. 6 minus 4 is supposed to equal 2. And, in fact, it does, so we know that this is the solution, or the ordered pair, that is the solution to the system of linear equations shown in the graph as well. So our assumption was correct. The next one, 3b, is a little more obvious, but again, you want to check this because it could be off a little bit. So it looks like the point is going to be right there, and that point is 0, negative 2. 0, negative 2. If you go no direction in the x direction, we're not going left or right. We are going down, so we're negative direction for y, which is a negative 2. All right, let's try it. 5 times 0 minus 4 times a negative 2 is supposed to equal 8. Well, the zeros just go away. 5 times 0 is 0. Negative 4 times negative 2 is a positive 8, and positive 8 does equal positive 8. So the first one checks out. The second equation, negative 0, which doesn't still do anything for 0, 2 times negative 2 is supposed to equal negative 4. Again, the 0 just becomes 0. 2 times negative 2 is a negative 4, and negative 4 does equal negative 4. So this is the correct assumption and ordered pair. That is the solution to this system of linear equations. All right, so that's a couple examples of graphs and determining the solution from the graph itself. Let's use a graphing calculator to solve for this system of linear equations. And we're going to use our calculator. There's a little button called y equals, and we'll push that button here in a minute. But in order to push the button for y equals and put an equation in there, we have to have it in y equals form. So we're looking for y equals mx plus b, or just maintaining that we get our y by itself. The order over here is not going to be too critical at this point. So we need to get y by itself, and you'll notice that these do not have y by themselves right now. So we're going to have to do that. Let's take and move the first equation over here and work it out and get y by itself. So we're going to take this one and say 0.2x minus 0.2y equals 2. We're going to move this to the other side, meaning we're going to subtract it. So we'll have negative 0.2y still left over here, 2 minus 0.2x. Okay? And then now we're going to need to get y by itself, so we divide by whatever's in front of y. Whatever's been multiplied to y, we undo that by division. So we divide by negative 0.2, divide this by negative 0.2, divide this by negative 0.2. Now if you notice, this is the same thing on top and bottom besides the x. This is the same coefficient divided by the same coefficient, so that's just going to be a positive 1. Okay, that's just going to be a positive 1. Negative over negative is positive. Same one, anything over itself is just 1. This is going to be a negative 10. I'm going to rearrange the order just to put them in order. So I'm going to have y is going to equal this positive 1x we'll put in the front. This is going to be a negative 10 when you put that in the calculator. 2 divided by negative 0.2. So this is going to be a minus 10. So that is the first equation. It's in y equals something, so we can put it into the y equals of the calculator, and that works. Let's do the second equation right here. 0.9x plus 0.6y equals 6. And again, we need to get the y term by itself, so we'll take this, move it over here, minus 0.9x. We'll divide by 0.6, 0.6, 0.6. And so every term will be divided by 0.6, getting y by itself on the left. Well, 0.6 here is just going to be 10. This is going to be a negative 1.5x. When you take 0.9 divided by 0.6, you get 1.5. It's negative divided by positive, so it stays as a negative. And so this is my second equation. Okay? Those are my two equations. And now I can go into y equals, and I can put those two equations in my calculator. And I'm going to do just that. Okay? So I'm going to press, if you're not there already, you press the y equals button right here. That's going to give you this y equals screen, and you can put both of these equations in. So I'm going to put these in. The first equation, I'm going to put in 10 minus 1.5x. Don't forget your x. I had several people taking quizzes that forgot to put the x in there. And when you do that, you're just going to end up with straight lines because there's no x term. That's the first equation. Second equation, x minus 10. X minus 10. Okay? I'm going to hit enter. I'm going to graph those, and we should see the graph is going to have two, lines that will cross, and where they cross is supposed to be our solution. We can get a pretty good assumption of where that's supposed to be, and then we can go to the table. If you go to second graph, it will take you to a table, and on the table we'll be able to tell exactly where it crosses. Most likely your calculator is going to probably start at 0, so you're going to have to move up or down and look for the y values to be the same in both columns here, y1, y2. So when x is whatever value it is, in this case 8, you'll notice that the y value, or the output value for the first equation is negative 2, and the y value for the second one is negative 2. That just means that these two lines cross at 8, negative 2. Because 8, negative 2 is a solution to both equations. All right, and you can see that from the graph too. If we showed you the graph, you'll look down here. That's about 8, negative 2. If you're looking at this, going from the origin out here to about 8 and going down about 2 spaces. So you can tell it is in that area. That could help you look for it on the table when you go to find on the table to confirm that. Okay, so the solution to this is going to be 8, negative 2. And again, the calculator found this for us. We could, if we were doing this on our own, go back and check that by plugging that in, and you would find it would work for you. All right, number 5, word problem here. You sell bracelets for $2 each and necklaces for $3 each at a local flea market. You collect $95, selling a total of 37 jewelry items. How many of each item of jewelry did you sell? This is not as hard as it may seem, trying to create the equations for this. It is going to be a system of equations. You're selling bracelets for $2 each and $3 for the necklaces, and it's going to equal $95. One key thing here is to keep your dollars in the same equation. All right. We know there's going to be 37 items, so I'm just going to go ahead and leave this as B and N. You can make this X and Y if you wanted to. That's up to you, whatever you feel comfortable with. I'm going to leave it as B and N so there's no confusion later as to what we're looking for and what we find. But I know that item for item here, if I'm going to take all the bracelets and all the necklaces that I sell and add those together, how many items total did I sell? Well, items, I've got 37. Now when it comes to the dollar amount, well, I know that $2 times however many bracelets I sell, I don't know what that is, but I know that 2 times B plus $3 for every necklace I sell, or 3 times N. Again, don't know what N is, but we can put that in here. We know that when we add those up, we're supposed to have $95. And if it helps you to put the little dollar signs there to know that you've put the right, numbers in the right equation, that might help you out. I had some people who used the 2 and the 3 when they're looking at items, and then, made it equal to 95. Made it equal to 37 instead of 95, and so, that gets you a little confused there. But just remember, items, the individual items will add up to be the total number of items sold, and the dollar amounts are going to have to somehow, go into an equation to equal the total dollar amount. This works out pretty easily. We can do this several different ways. We could graph this. We could put it in the calculator. We could substitute. We could eliminate. I'm going to do this by substitution. And I'm just going to solve for n first. So that means I'm going to take my b and move it across. So I'm going to have n is going to be equal to 37 minus b. And I can take that whole expression and plug it in where I see an n in the other equation. So let's do that. We're going to have 2 times b plus 3 times n. Well, n's going to be 37 minus b. And that's going to equal $95. Then when I do my algebra to solve for b, I'm going to have to distribute the 3. So I'm going to have 2b plus 111 when I multiply 3 times 37 minus 3b. It's going to equal 95. Okay, I'm going to combine the b terms together, and I'm going to get a negative b, because negative 3 plus 2 will be a negative b, negative 1b if you want to say that. I'm going to move the 111 to the other side, which means I'm going to have to change its sign. So I'm going to have to subtract it from both sides. Alright, so I've got my negative b brought down. 95 minus 111 is a negative 16. And I can multiply by negative 1, or divide by negative 1, or just know that I can change both the signs on both sides at the same time here. B is just going to equal 16. So, bracelets. We have 16 bracelets. And we can take this now, plug it into the necklaces equation or expression, and we can find out that necklaces are just equal to the total number of items, 37, minus the number of bracelets, which was 16. So the necklaces is just going to equal 21, and that's all we need to know at this point. We have 16 bracelets and 21 necklaces. And we've solved this system of linear equations pretty easily. Okay. Alright, let's look at the back. Again, if you're watching this video and we're moving too fast, you can slow this down, pause it, whatever. And if we're not moving fast enough, you can go to your settings and change the speed to be 1 1/4, 1 1/2, or 2 times as fast so that you can go a little faster. On 6, 7, and 8, we are solving by substitution. So the previous problem that we just solved is kind of a lead into the next set of questions that we have here. And we know we've got 2 different options here. I've got y equals this expression, or I have x equals that expression. So we can pick either one to plug in and solve for into the other equation. I'm just going to use the x, and I'm going to plug it in to the x in the first equation. So I'm going to have y equals 10 minus 2 times y minus 4. Instead of x, I'm plugging in y minus 4. Okay? Now I'm going to need to distribute this negative 2 into my equation. So this is going to be 10 minus 2y, because negative 2 times y is negative. Negative times negative 4 is going to be a positive 8. Okay, so y equals 10 minus 2y plus 8. And then I can combine my 10 and my positive 8 together. So I'll have y equals negative 2y plus 18. 10 plus 8 is 18. Then I'm going to move this to the other side, which means we're going to have 2y plus y. So 3y is going to equal 18. I can solve for y by dividing by 3. Y is going to equal 6. And knowing that y equals 6, I can take that, plug it back into that bottom equation, and we'll see that x equals y minus 4, or x equals 6 minus 4, because we just plugged that in. And 6 minus 4 is just 2. So I have 2 and 6 as my ordered pair. And that is the solution to this system of linear equations, 2, 6. Okay, for number 7, this one works out pretty nicely too. X equals 5y here, or x equals the whole thing that's up here. I'm going to take this part right here and just plug it in place of x right there. Plug it in place of x right there. So 4y plus 1 equals 5y. And this is real easy. I can do this in one step. I can just put the y value over there, which means I'm going to have to minus it. And when I do that, 5y minus 4y is going to equal a 1y, and so y just equals 1. And y equaling 1, I plug it back into this bottom equation, and real fast I'm going to see that x is 5 times 1, or x is just equal to 5. So the solution to this system of linear equations is 5, 1. That's my ordered pair. Answer to number 7. All right, number 8. Number 8, we're going to have a very easy question. This was somewhat of a gimme question on our quiz. 5y equals 10. Well, I can solve real quick for y by just dividing by 5, and we know that y is going to equal 2. And this didn't really require us to do a lot of substitution, other than we're just substituting in now the value for y into the bottom equation. So x minus 3 times 2 equals 4. So x minus 6 equals 4. I'll move that to the other side, which means I change the sign. So I'm going to add it instead of subtract it. So x is just going to equal 10. So the solution to this system of linear equations is 10, 2. Most people got that one correct on the quiz, and should have. They should have gotten that one correct. All right, let's look at the word problem number 9. A humane society has 73 dogs and cats to be adopted. So dogs and cats. I know Siri does cats and boots and cats and boots and cats and boots, but we're going to do dogs and cats and dogs and cats and dogs. Okay, that was just a side joke. All right, so here we go. Dogs, I'm going to represent with a D, and cats with a C. I know that's original, and I know that you probably wouldn't have thought of that, but, you know, teachers are always the smart ones, and so we're going to use D and C here. And we know that dogs plus cats, all the dogs and all the cats added together are going to equal how many animals total? 73. Okay, so dogs plus cats equals 73. Now, the number of cats, C, is just means equals. So I'm building my second equation here. 10 more than means plus 10. So I'm going to add 10 to something, right? And twice the number of dogs just simply means 2D. So if you'll take these word problems and just kind of break them into their parts and understanding what certain terms mean, anytime you see is, it's going to be the equal sign. So I have a great example of substitution here. I've got C already isolated, and I can plug that right in to the top equation for C. So D plus C is 2D plus 10 is going to equal 73. All right, so now I can solve for D, and when I solve for D, I can plug that back in to solve for C. So the number of dogs, I'm going to add these common terms here together, these like terms. We're going to have 3D plus 10 equals 73. I'm going to take and move the 10 across, which means I'm going to subtract it from both sides. So now 3D equals 63. And when I divide by 3 and divide by 3, the number of dogs is going to equal 21. So the number of dogs that the Humane Society has to be adopted is equal to 21. All right, let's solve for the rest of it now. Cats is equal to 2 times the number of dogs. So we're plugging this back in over here to this equation. 21 plus 10. Well, 2 times 21 is 42. Plus 10 is going to equal 52 total. So we have 21 dogs and 52 cats, and if I add those together, I do get 73 animals total. And that's the answer to number 9. Number 10, 11, and 12, we're solving by elimination. The first one is set up very nicely because we're looking for the same coefficient or opposite signs of the same coefficient. And here we have 1s. So because they are opposite sign, we are going to add the 2 equations. We'll add these terms. We'll add these terms, circle the sign with them so you don't have a sign error, and we're going to add those terms together. We're going to have 7x plus 0. These are eliminated. That's where we get the term. Solving by elimination, and this is going to be equal to 14. So now, I'm going to divide by 7 on both sides, and x is going to equal 2. And then I'm going to take this value 2 and plug it back into, I'm going to use the bottom equation here. 3x, well, x is actually 2, so let me rewrite that. 3 times 2 plus y equals 9. So I've plugged that in place of x. 3 times 2 is going to be 6 plus y equals 9. I'm going to move the 6 across, meaning I'm going to subtract it from both sides. So that goes away. I've subtracted it away. Moved to the other side. Y equals 3. So the solution to this linear set of, system of linear equations is going to be 2, 3. And we're done with 10. Number 11, they're going to have us do a little bit of work. We don't have the same coefficients in front of x or y, but we can pick whichever one we want to work with and move forward. So I'm going to pick x, and I'm going to have to multiply the bottom equation by 2. And this is still going to be an equivalent equation. We've talked about it in previous chapters. But I'm going to multiply this by 2. So I'm going to get, actually, I tell you what. If I multiply by 2, I get a positive 2x and a positive 2x. If I multiply by negative, then that will go ahead and give me a negative 2x and let me just add all of my terms together, which is a little simpler, we can say, to do. So if I multiply this new equation, it's going to be negative 2x plus 2y, negative times negative is positive, equals negative 20. Then I'm going to rewrite the bottom or the top equation below here. So 2x negative 7y equals 5. And I'm going to add those because I have opposite signs in front of my x coefficients there. Similar coefficients. So I'm going to add these together. So when I add these together, I get a 0. When I add my y terms together, I get a negative 5y. Positive 2, negative 7. That's going to equal a negative 15. Negative 20 and 5 is negative 15. Divide by negative 5. Divide by negative 5. Y is going to equal a positive 3. Y will equal a positive 3. I can just plug that back in to this bottom equation right here. So then x minus a positive 3 is going to equal 10. Well, I'm going to just move that over. That means I'm going to add it to both sides. When I move it to the right, you've got a negative 3, so I'm just going to add 3 to both sides. So x is going to equal 10 plus 3, which is 13. So the solution to this set, keep this divided here, the solution to this system of linear equations is going to be 13, 3. 13, 3. Now, on number 12, they make us do a little more work than we did on 11. Now I can't just multiply one equation by a number to get it to a common coefficient. I have to multiply both of them. So now I'm looking for the least number if possible, because we deal with smallest numbers if we can. As we move through the equation, it makes it a little easier. Move through solving the equation makes it easier. So I'm going to use the x values. I can get to a 10 here with 2 and 5. They can both be multiplied by a factor to get to 10. These two, if I went with y values, the smallest number we would have here would be a 24. You can multiply the top one by 2 to get 24, the bottom by 3 to get 24. But I'm going to go with the first part here, the x terms. I'm going to go with 2 for the top and 5. Now in this case, they can both be positive terms, because 2 times negative 5 is going to be a negative 10. 5 times 2 is going to be a positive 10. So that gives me a negative and a positive. Still lets me add them and eliminate my x terms. So rewriting this top equation, I'm going to have negative 10x plus 24y equals 16. Rewriting the bottom equation, I'm going to have a positive 10x minus 40y equals 0. And then, because I have opposite signs, I can add all of my terms. So these will go away. This will become a negative 16y, and 16 plus 0 is 16. I'll divide by negative 16, divide by negative 16. Y is going to equal a negative 1. So I found y, and now I'm going to plug this back into the positive version of x. It's kind of the way I like to do it. You can plug it into either one, it'll still work. And so I'm going to plug it into the positive version of x, or the equation with the positive x in it, so I can solve for x. So 2x minus 8 times a negative 1. It's supposed to equal 0. So 2x is going to be added to 8 to equal 0. And if I'm going to move this across, then I'm going to have a negative 8 over here. That will go away. When I divide by 2 on both sides, I'll squeeze this in. X is going to equal negative 4. So now I have both of my values for x and y here. The solution to this system of linear equations is going to be negative 4, negative 1. And again, I can plug that back into these equations and check those as I'm going along here to know that I have the right answer. For sake of time, we're going to go ahead and push forward to the last problem. Number 13 is another word problem. You and your friend are buying throw blankets with your names embroidered on them. The cost of the throw blanket is X dollars, and that's important to note. It's X dollars for the blanket, and the cost of each embroidered letter is Y dollars. Okay? Your name has 6 letters in it. 6 letters, and I'm going to have to pay for a throw blanket in both of these cases, you're going to notice. The total cost of my blanket is $29. Well, I know the cost of the blanket itself is X. I'm going to have to add to that however many letters I have in my name times the dollar amount, Y, for the letter. So 6Y, and that's going to equal $29. For my friend, they only have 3 letters in their name. The total cost is $24.50. They're still paying for a blanket as well. And the only difference is that they're paying only for 3 letters in their name times Y, and that's going to equal $24.50. Okay? So now, this is pretty easy. We can do elimination, and this will work out real nice. It's the same sign. If we use our x terms here, we can make those go away by just subtracting everything on the bottom. Another way to look at this is, if I'm subtracting everything in the bottom, what am I doing? I'm just changing the sign to a negative for everything on the bottom, and really I'm just adding a negative. That's all subtracting is just adding a negative. So if I do that, this will go away. This will become 3y. This will become 450. And if I divide both sides by 3, thus solving for y, I will get $1.50 for every letter. So my letters are equal to $1.50 a piece. Okay? Now I can plug that $1.50 into either one of these equations. I'm just going to pick the top one to solve for x. X plus 6 times $1.50 is going to equal $29. Well, 6 times 150 is actually 9. And if I'm going to move this positive 9 across over here, it just means I'm going to subtract 9 from both sides. It's positive, so I'm going to subtract 9 from both sides. That goes away. And x is going to equal $20. So the blanket is equal to $20. And we have solved number 13. All right, I hope this helps you guys out. Please study for the test. The test will be Monday. You can use a 3x5 standard note card front and back as a cheat sheet for the test. You guys have a great day and a great weekend.